Who here knows what glycolysis is? Anyone? Yeah?
It's a breakdown of glucose.
Yep. According to Merriam-Webster Dictionary, glycolysis is an enzymatic breakdown of carbohydrates as glucose by the way of phosphate derivatives with the production of pyruvic or lactic acid, and energy stored in high energy phosphate bond known as ATP. In other words, it's how the body breaks down glucose and produces energy. Glycolysis is a major metabolic pathway, and today I'm going to talk to you on why it's important and the steps of glycolysis. To begin with, I will talk to you guys on why it's important. According to Nelson and Cox, author of the textbook Leninger, Principle of Biochemistry, published in 2008, glucose is a major energy source. Not only is it a major energy source, but a lot of the other metabolic pathway feeds into glucose. These other pathways include fructose breakdown, the citric acid cycle, mannose breakdown, and pentose phosphate pathway. The overall goal of glycolysis is produce ATP. One cycle of glycolysis produces 4 ATP and 2 NADHs. Now, NADHs are similar to ATP, they're just not as high energy yielding. Now that I've talked to you on why glycolysis is important, I will go through the steps of the glycolysis cycle. Now, the following steps and images on my slide are from the Principles of Biochem 4th edition by Voet and Voet, published in 2012. So to begin with, we need to obtain glucose. And in order to obtain glucose, we must break it down from sucrose or lactose. And in order to break down sucrose, you're going to need the enzyme sucrase and water, and that produces fructose and glucose. And to break down lactose, you need lactase and water, and that produces galactose and glucose. Now that we have glucose, the simple structure of glucose, this is what it looks like. Now, each carbon here is labeled, and that's going to help us identify where things happen within the cycle. And so step 1 is going to be a tagging process with a phosphate group. Now, this phosphate group is going to keep the structure from leaving the muscle area and allows us to proceed with glycolysis. So in order to tag it, we're going to need a hexokinase with a magnesium assist. And what it does is it's going to phosphorylate this group here at the 6 carbon position. And it also requires energy. So it's going to take energy to produce energy is what the point is here. But this hexokinase is going to attach a phosphate group to this position here, and it's going to produce glucose 6-phosphate or G6P. Now, once we have G6P, we can move on to the next step, which is changing the structure of G6P into fructose 6-phosphate. Now, fructose 6-phosphate has the same number of carbons as glucose does. That's why it's able to just switch like this. And the enzyme that we use here is phosphoglucose isomerase. And the important thing here is to notice that there's 3 carbons on this side and 3 carbons on this side. Now that's going to be extremely important on our next coming steps here. So from fructose 6-phosphate, we're going to again phosphorylate this fructose. We're going to do it by phosphofructose kinase along with a magnesium assist. And again, we see that we're using a ATP to attach that phosphate group on. Now what it does is going to attach a phosphate group at the 1 position, which is going to be here. So now we have fructose 1,6-bisphosphate. From the fructose 1,6-bisphosphate, it's going to linearize, in other words, become a straight line. And then the enzyme aldolase, which is used to cut, is going to come in between the 3 and 4 position carbon and split in half. From there, we're going to get 2 products of dihydroxyacetone, or DHP, and glyceraldehyde 3-phosphate, GAP. Now these two here, this DHP one can be easily switched to this one, by the way of triphosphate isomerase. But we're going to proceed with the GAP here. So once we have the GAP, we're going to move on to what is known as the payoff phase, and this is where we start getting energy back in. So from GAP, we're going to use glyceraldehyde 3-phosphate dehydrogenase. And what that does is it's going to phosphorylate this first carbon here, allowing this hydrogen to free up and attach to this NAD+. And over here we'll produce a 1,3-bisphosphate glycerate along with an NADH, which is our first form of energy produced. It's not as great as ATP, but it is a form of energy. So from the 1,3-bisphosphate glycerate, we're going to move on to our first production of ATP. Now this phosphoglycerate kinase, what it does is it's going to remove this phosphate group and allow it to attach to this ADP group here and produce ATP and 3-phosphate glycerate, or 3PG. Once 3PG is produced, we're going to move over this bottom phosphate group up to that second carbon. And that is done by phosphoglycerate mutase. And what this mutase does is just move this 3 from the 3 position to the 2 position. So instead of 3PG, we have 2PG. And once we have 2PG, we move on to using enolase. And what enolase does is just sucks water out from this structure and produces phosphoenolpyruvate. And it's just going to release that water into our bodies, just other systems that can use it. And once we get phosphoenolpyruvate, or PEP, we're going to move on to our last payoff phase, where another ATP is produced by the use of pyruvate kinase. This pyruvate kinase, much as the similar step where we got our first ATP, is going to remove this phosphate group and allow it to attach to the ADP group and produce ATP. And then we end up with pyruvate. Pyruvate is the last structure of glycolysis, because from there on it can go into the citric acid cycle and is used for amino acid breakdown, which is essential for other parts of our body. So in conclusion, it is very important that everyone knows about glucose and how it works in our body and how we obtain our energy. And if we weren't able to have any energy, then we won't be able to do anything. Does anybody have any questions?
Work safer?